Welcome to Marketing Statistics. In this video we study the correlation and simple linear regression. There are many different types of correlation coefficients, but the one we will use in this book is the Pearson product moment correlation, which we will call R6. What is a correlation? Basically, a correlation is a number between 1 and plus 1 that summarizes the relationship between two variables, which we will call x and y. A correlation can be either positive or negative. The positive correlation means that x increases, y increases. A negative correlation means that x increases, y decreases. In statistics books, this part of the relationship is called the direction of the relationship i.e., it is either positive or negative. The correlation also tells us the magnitude of the relationship between x and y. As the correlation approaches closer to plus 1, we say that the relationship is strong and positive. As the correlation approaches closer to 1, we say that the relationship is strong and negative. A zero correlation means that there is no relationship between x and y. This means that neither x nor y can be used as a predictor of the other. A good way to understand what a correlation means is to see a picture of the scattered plot of points produced in a chart by the data points. Let's suppose that you want to know if variable x can be used to predict variable y. We will place the predictor variable x on the x-axis, the horizontal axis of a chart, and the criterion variable y on the y-axis, the vertical axis of a chart. Suppose, further, that you have collected data given in the scattered plots below. See Fig. 6.1 through Fig. 6. Figure 6. 1 shows the scattered plot for perfect positive correlation of R141, 0. This means that you can perfectly predict each y value from each x value because the data points move upward. And 2. The right along perfectly. Sittings can predict each y value moderately well because you can draw a picture of a football around the outside of the data points that move upward and to the right, but not along the straight line. Shows the scattered plot for a low, positive correlation of R1,423. This means that each x value is a poor predictor of each y value because the picture you could draw around the outside of the data points approaches the circle in shape.
We have not shown a figure of a zero correlation because it is easy to imagine. What it looks like is a scatter plot. A zero correlation of R1/4 means that there is no relationship between x and y. The picture drawn around the data points would be a perfect circle in shape, indicating that you cannot use x to predict y because these two variables are not correlated with one another. Figure 6.
Figure 6. Shows the scatterplot for a low negative correlation of R22, which means that each x is a poor predictor of y in an inverse relationship, meaning that as x increases, y decreases. See Fig. 6.4. In this case, it is a negative correlation because the football you could draw around the data points slopes down and to the right. Shows the scatterplot for a moderate, negative correlation of R39, which means that x is a moderately good predictor of y, although there is an inverse relationship between x and y, i.e. as x increases, y decreases. See Fig. 6.5. In this case, it is a negative correlation because the football you could draw around the data points slopes down and to the right. Figure shows a perfect negative correlation of 1,0, which means that x is a perfect predictor of y, although in an inverse relationship such that as x increases, y decreases. The data points fit perfectly along a downward sloping straight line.
Let's explain the formula for computing the correlation R so that you can understand where the number summarizing the correlation came from.
Understand where the correlation number that ranges from 1, 0 to +1, 0 comes from. We will walk you through the steps involved to use the formula as if you were using a pocket calculator. This is the one time in this book that we will ask you to use your pocket calculator to find a correlation. But knowing how the correlation is computed step by step will give you the opportunity to understand how the formula works in practice. To do that, let's create a situation in which you need to find the correlation between two variables. Suppose that you have been hired by a manager of a supermarket chain to find the relationship between the amount of money spent weekly by the chain on television ads and the weekly sales of the supermarket chain in St. Louis. You collect the data from the past 8 weeks given in. For the purposes of explanation, let's call the weekly cost of TV ads as the predictor variable X, and the weekly sales as the criterion variable Y. Notice that the data for the cost of TV ads for each week is in thousands of dollars, $000. For example, the TV ads for week 6 cost $3.300. And when we move the decimal place 3 places to the left to change the amount to thousands of dollars, this becomes 3. Similarly, the weekly sales for week 6 were really $92,000 as those data are also in thousands of dollars format, $000. Notice also that we have used Excel to find the sample size for both variables, X and Y, and the mean and STDV of both variables. You can practice your Excel skills by seeing if you get the same results when you create an Excel spreadsheet for these data. Now, let's use the above table to compute the correlation R between the weekly cost of TV ads and the weekly sales of this supermarket chain using your pocket calculator.
Using Excel to compute a correlation between two variables. Objective: to use Excel to find the correlation between two variables. Suppose that you have been hired by the owner of a supermarket chain in St. Louis to make a recommendation as to how many shelf facings of Kellogg's Corn Flakes this chain should use. A shelf facing is the number of boxes of the cereal that are stacked beside one another. Thus, a shelf facing of 3 means that 3 boxes of Kellogg's Corn Flakes are stacked beside each other on the supermarket shelf in the cereals section. You randomly assign supermarket locations to your study, and you randomly select the number of facings used in each supermarket location, where the number of facings range from 1 to 3 facings. You track the weekly sales in thousands of dollars of this cereal over a 10-week period, and the resulting sales figures are given in. You want to determine if there is a relationship between the number of facings of Kellogg's Corn Flakes and the weekly sales of this cereal. And